बिस्मिल्लाहिर्रहमानिर्रहीम। आज हम डीसी जनरेटर की थ्योरी पढ़ेंगे। स्टार्ट करते हैं। An electric generator is a machine that converts mechanical energy into electrical energy. Electric generator is based on the principle that whenever flux is cut by conductor an EMF is induced which will cause a current to flow if the conductor circuit is closed. The direction of induced EMF and hence current is given by framing right-hand rule. Therefore, the essential component of generator are magnetic field, group of conductor, motion of conductor with respect to magnetic field. As an energy converts, DC generator is not 100% efficient because there are energy losses in machine. Instruction of DC generator or motor. All DC machines have five principal components: field system, armature core, armature winding, commutators, brush. Field system. The function of field system is to produce a uniform magnetic field within which the armature rotates. Field coils are mounted on the poles and carry DC exciting current. The field coils are connected in such a way that adjacent poles have opposite polarity. Armature core. The armature core is key to machine shaft and rotate between the field coils. The purpose of laminating the core is to laminating the armature core is to reduce eddy current loss. Armature winding. The slot of armature core hold insulated conductors that are connected in suitable manners. This is known as armature winding. This is the winding in which working EMF is induced. The armature conductors are connected in series parallel. The conductors being connected in series so as to increase the voltage and in parallel paths so as to increase the current. Commutator. Commutator is a mechanical rectifier which converts the alternating voltage generated in the armature winding into direct voltage across the brushes. Commutator on the shaft of machines. Commutator is made of copper segments insulated from each other by mica sheets and mounted on the shaft of machine. Depending upon the manner in which armature conductors are connected to the commutator segment, there are two types of armature winding in DC machine: lamp winding and wave winding. Brushes. The purpose of brushes is to ensure electrical connection between the rotating commutator and stationary external load circuit. When machine is acting as a generator, the brushes carry current from commutator to external stationary load. In these machines, in case the machine is acting as a motor, the field supply current to the commutator. Type of armature winding: simple wave winding. To sum up, in simple wave winding, there are two parallel paths irrespective of number of poles of machine. Each parallel path has Z by 2 connector in series. Z is total number of armature conductor. EMF generated is equal to EMF over parallel path. Total armature current IA is equal to 2 multiply current over parallel path. Simple lap winding. To sum up, in simple lap winding, there are as many parallel paths as the number of poles of machines. Each parallel path had Z by 2 connectors in series where Z and P are the total number of armature connectors and poles respectively. EMF generated is equal to EMF over parallel path. Total armature current is equal to P multiply current over parallel path. Choice of armature winding. The number of coils in series in each parallel path is less in lap than in wave winding armature. Therefore, the current carrying capacity of lap winding is greater while in terminal voltage of wave winding will be greater. जहाँ पे हमें क्रिटिकल वोल्टेज हाई मैक्सिमम वोल्टेज चाहिए होगा तो वहाँ पे हम वेव वाइंडिंग यूज़ करेंगे और जहाँ पे हमें करंट हाई करंट रिक्वायर्ड होगा वहाँ पे हम लैप वाइंडिंग यूज़ करेंगे। स्मॉल मशीन में वेव वाइंडिंग यूज़ होती है और लार्ज मशीन में लैप वाइंडिंग यूज़ होती है। In small machine, current carrying capacity is not generally critical. Therefore, in order to obtain suitable voltage, wave winding are often used. In large machines, suitable voltage are easily obtained because of relatively large number of armature conductor available and current capacity is more critical. Therefore, large machines generally use lap winding. A is equal to 2 for ये फार्मूला है EMF का ये फार्मूला है जनरेटेड EMF का P5ZN/60A लैप वाइंडिंग के लिए A की वैल्यू होगी 2 और वे लैप वाइंडिंग के लिए होगी P पैरेलल पाथ। Armature resistance. The resistance offered by armature current is known as armature resistance. Include resistance of armature winding, resistance of brushes. The armature resistance depend upon the construction of machine except for small machine. Its value is generally less than 1 ohm. Type of DC generator. दो तरह के जनरेटर होते हैं, एक होता है सेपरेटली एक्साइटेड डीसी जनरेटर, एक होता है सेल्फ एक्साइटेड डीसी जनरेटर। द बिहेवियर ऑफ डीसी जनरेटर on load depend upon the method of seek excitation adopted. Separately excited DC generator में DC generator whose field magnet winding is supplied from the independent external source is called separately excited DC generator. एक्सटर्नल डीसी सोर्स इसको हम एक्साइट करते हैं। The water output depend upon the speed of rotation of armature and field current. The greater the speed and field current, the greater the generated EMF. Self-excited DC generator, a generator whose field magnet winding is supplied current from the output of generated itself is called self-excited generator. There are three types of self-excited generator depending upon the manner in which field winding is connected to armature. Series generator, shunt generator, compound generator. Series generator. In series wound generator, the field winding is connected in series with armature winding so that whole armature current flows through the field winding as well as load. Shunt generator. In shunt generator, the field winding is connected in parallel with armature winding so that terminal voltage of generator is applied across. The shunt winding has many turns of having high resistance and therefore only part of armature current flows through the shunt field winding and rest flows through the load. Compound generator. In the compound wound generator, there are two sets of field winding each pole. One is in series and other is in parallel with armature. Short shunt, which only in which only shunt field is winding, is in parallel with the armature winding. Long shunt, in which shunt field winding is in parallel with both series field. Both field, series field and armature winding. Losses in DC machine. The losses in DC machine generator or motor may be divided into three classes: copper loss, iron or coal loss, mechanical loss. All these losses appear as heat loss, rise in temperature of machine. They also lower the efficiency of machine. लॉसेज इन डीसी मशीन कॉपर लॉस में होता है आर्मेचर कॉपर लॉस, शंट फीड कॉपर लॉस, सीरीज फीड कॉपर लॉस। आयरन लॉस में होता है हिस्टेरिसिस लॉस, एडी करंट लॉस। मैकेनिकल लॉसेज में होता है फ्रिक्शन लॉस और विंडेज लॉस। कॉपर लॉस इज द लॉसेज अकर ड्यू टू करंट इन द वायरस वाइंडिंग ऑफ मशीन। आर्मेचर कॉपर लॉस आई स्क्वायर आर ए, shunt field copper loss I, shunt spare R shunt, series field copper loss I series spare R is R series spare. There is also brush contact loss due to brush contact resistance. The resistance between the surface of brush and surface of commutator. This loss is generally included in armature copper loss. Iron loss. These losses occur in armature of DC machine and are due to the rotation of armature in magnetic field of the poles. There are two types of hysteresis loss and eddy current loss. Hysteresis loss is given by pH 5 V maximum 1.6 F V maximum flux density in the armature in Weber per meter square. F is the frequency of magnetic level cell frequency given दी जाती है। NP over 120 where N is in RPM, V is the volume of armature in meter cube. Stresemann hysteresis coefficient. In order to reduce this loss, DC machine armature core is made of such material which have low value of Stresemann hysteresis coefficient is silicon steel. Eddy current loss. When armature rotates in the magnetic field of pole, an EMF is induced in it which circulates eddy current in the armature core. The power loss due to eddy current is called eddy current loss. In order to reduce this loss, armature core is built up of thin lamination insulated from each other by thin layer of varnish. Eddy current loss given होता है E KE, इसका कांस्टेंट होता है B maximum square F square T square V watt. B maximum है maximum flux density in the core in Weber per meter square. Frequency of magnetic reversal in hertz. Thickness of lamination, जितनी इसकी थिकनेस ज़्यादा होगी एडी करंट लॉस उतना ही ज़्यादा होगा। हम थिकनेस को कम करके इसकी एडी करंट लॉस कम कर सकते हैं। वॉल्यूम ऑफ कोर इन मीटर क्यूब। मैकेनिकल लॉस. These losses are due to friction and windage. Friction loss is bearing, friction, brush friction etc. Windage loss, i.e. friction of rotation armature. These losses depend upon the speed of machine, but for given speed they are practically constant. Note: iron losses and mechanical losses together are called stray losses. Constant and variable loss. The losses in DC generator may be subdivided into constant loss and variable loss. The constant losses में होते हैं आयरन लॉसेज, मैकेनिकल लॉसेज और शंट फीड कॉपर लॉसेज। ये डीसी जनरेटर में कांस्टेंट होते हैं आयरन लॉसेज, मैकेनिकल लॉसेज और शंट फीड लॉसेज। और वेरिएबल लॉसेज में होते हैं The losses in this nature which validate load are called variable losses. Copper loss in armature winding, copper loss in series field winding. Total loss is equal to constant losses plus variable losses. Condition for maximum efficiency है कि the efficiency of DC generator is not constant but varies with load. Consider a shunt generator delivering a load constant at terminal voltage V. Efficiency given होती है output over input. मैक्सिमम एफिशिएंसी कब हमारे पास आएगी जब हमारे पास ये होगी कंडीशन वेरिएबल लॉस इज इक्वल टू कांस्टेंट लॉस हो जाएगा. Hence, the efficiency of DC generator will be maximum when the load curve is such that variable loss is equal to constant loss. Armature reaction. Current flowing through a armature conductor also create a magnetic flux called armature flux. The only flux acting in DC machine is that due to the main pole called main flux. The current flowing through an armature conductor also create a magnetic flux called armature flux that distort and weaken the flux coming from the poles. This distortion and field weakening takes place in both generator and motor. The action of armature flux on the main flux is known as armature reaction. The phenomenon of armature reaction is in DC generator is shown in figure. When generator is on no load, a smart current flowing in the armature does not applicably affect the main flux coming from the pole. When the generator is loaded, current flowing through an armature conductor set of flux by superimposing phi 1 and phi 2, we obtain the resultant flux phi 2. This unequal field disturbance produces the following two effects. The main field flux is distorted due to higher flux density at pole tip B. The saturation sets in. Consequently, the increase in flux at pole tip B is less than decrease in flux under pole tip A. Flux phi 2 at full load is therefore less than flux phi 1 at no load. Problem of armature reaction. Armature reaction in DC machine distort and weakens the main flux. This creates the following two problems. Armature reaction may decrease the main flux by 10%. This causes the generated EMF in the generator to fall with increase in load current. To ensure good commutation, the brush must be placed in neutral zone. Hence, however, due to distortion of flux, the neutral zone is shifted if the load varies frequently. If shifting of brush position is not practicable. Commutation. Two-pole layout generator. There are two parallel paths between the brushes. Therefore, each coil of winding carries one. There are two parallel paths between the brushes. Therefore, each coil of winding carries one half of the total current entering or leaving the armature. The current in the coils connected to brushes are either are toward the brush or are get away from the brush. Negative brush, therefore the current in the coil will reverse as the coil passes a brush. The reversal current in the coil as the coil passes brush is called commutation. The complete reversal of current in a coil at a uniform rate as the coil passes a brush is called ideal commutation. When commutation takes place, the coil undergoing commutation is short-circuited by brush. For ideal commutation, following assumptions are made. Insulation between Commutator segment is of negligible thickness as compared to width of communication commutator. The resistance of armature coil is negligible as compared to resistance of carbon brush in contact with copper segment. The armature coil has negligible inductance. ये जो मेन पॉइंट थे थ्योरी में जो कि इम्पोर्टेंट थे वो मैंने आपको हाईलाइट करके डिस्कस कर दिए हैं। नेक्स्ट लेक्चर में हम इस डीसी जनरेटर के एमसीक्यूज करेंगे जो इम्पोर्टेंट हैं। उम्मीद है कि ये आपके लिए काफ़ी हेल्पफुल साबित होगा लेक्चर। अगर आप मेरे चैनल पर नए हैं तो मेरे चैनल को सब्सक्राइब कर लें, बेल आइकन को प्रेस कर लें ताकि नेक्स्ट कोई वीडियो मैं अपलोड करूं तो उसकी आपको अपडेट मिल सके। ये हमने इसके डीसी जनरेटर की थ्योरी पोर्शन कवर किया है। नेक्स्ट में हम इसके एमसीक्यूज कवर करेंगे डीसी जनरेटर के जितने भी हैं।